Okay, hopefully you had a chance to go back and do the now you try these. So I'm just going to leave these up here for a quick second so you can check them. This angle was on the exterior, so I used the exterior angle theorem. So these two add up to the one on the outside. This one I used the equilateral theorem that says all of these are equal, so you can pick any two you want to set equal to them, each other. This one down here, there was no special markings anywhere, so I just said the three angles add up to 180 in a triangle. This one I've highlighted. They did have special marks on this one, so if they have two special sides, that's called an isosceles triangle theorem, which says then these angles are also equal. Alright, so I'm going to redo these bottom ones. The video cut off when I was trying to do those before, so I'm going to see if it'll record this time to do these last examples with you. Alright, so use your knowledge of all properties and previous angle relationships. So, like for instance, if these are all marked, the little marks got kind of slightly off, but if all three sides are marked, we know that's called equilateral. So to find angle x up here, if these sides are all equal, we know those angles are all equal. So angle x is going to equal 60 degrees because of the equilateral equiangular theorem. In this triangle over here on the right, we know that this is 90 degrees because it's a right angle. And in a triangle, all three angles add up to 180. So if you did like 60 plus 90 plus y should equal 180. So to find angle y, we would need to subtract the 60 and 90 to the other side. So 180 minus 60 minus 90 equals 30. Y equals 30 degrees. Okay, and then we have one more here. This angle down here on Z is not inside the triangle. So if it's not inside the triangle, it's on the outside, which is called the exterior. And the exterior angle theorem says that these two should add up to the one on the outside. So 30 plus 38 is going to equal angle Z, which is 68. So angle Z is 68. Angle Y is 30. And angle X is 60. Okay, so there's just some examples of how we could use what we've done in the past. Another way to do this, if you forget the exterior angle thing, is to take like 180 minus 30 and minus 38. If you didn't see that that's an exterior, you could figure out this angle here is 112. And then a straight line, you could take 180 minus 112 will also get us 68 for that angle Z. So just another option if you don't recognize the exterior angle one. Alright, this next one, we have angle 1 is in a triangle with two others. So angle 1 plus 61 plus 68 should equal 180. So I'm going to take 180 minus 61 and minus 68. So angle 1 equals 51 degrees. Okay. Angle 2 here is considered a vertical angle, which we learned about in Unit 1. Vertical angles are equal, so angle 2 is going to equal 61 degrees. So we have angle 1, we have angle 2. So if this is 61 degrees, and we know this box is 90 degrees, we can figure out angle 3. Angle 3 is missing, so again you could do like angle 3 plus 61 degrees plus 90 degrees should equal 180. So we can figure out the missing angle by subtracting those from 180. So 180 minus 61 minus 90 leaves us angle 3 is 29 degrees. So key things, angles in a triangle add up to 180. Straight lines add up to 180. Isosceles has two equal ones. Angles and equilateral, they're all equal, so they're all 60 degrees.